Hello everyone, welcome back to Particulate Technology. So let us now learn a few things again in the seventh session. So before we start our present session, so let us just go back to quickly recall what we learned in the previous session. So in the previous class, we talked about the ideal screen and actual screen. So what is an ideal screen and actual screen, and what are the differences between these two terms that we discussed in previous class. Then we discussed about the capacity and effectiveness of the given screen, and also we had a discussion on the various factors that might affect the screening performance or screening efficiency. So these are the contents for today's class. So from now onwards, we'll be starting a discussion on the other methods of separation of particles other than screening. So today we'll take up one such method, that is classification of solids. So the classification of solids is carried out in a equipment called gravity settling tank. So we need to understand its construction and the working principles. So the same principle is used in another kind of classifier or a separating equipment called cone classifier. So we are going to learn the working principle and the construction of all these equipments. Coming to classification. So before that, let me tell you what are these the other separation methods. The screening is a most widely used method for separating the particles of different sizes in industries. However, in certain cases, screening is not an effective method. So that is especially when a given mixture of particles that are used in a application may contain a very fine particles. So in such a case, the screening may not give you the required kind of performance. So in such a case, you have to go for some kind of other operations, and these other separation operations are the one which separate the particles of a given mixture of solid based upon specific properties of the materials. So like in classification, the behavior of the solids in a fluid is utilized to separate the particles into different fractions. In the same way, we have other methods like jigging, which is based on the specific gravity or the density of the particles. Then we have magnetic separation that utilizes the magnetic properties of the materials to effect a separation. Then we have flotation, where the surface characteristics of the material is utilized for effecting a separation. Then you have electrostatic separation. The electrical characteristics of particles are used as a basis for separation. So let us now take up all these methods one by one to understand their principles and how they can be used to separate the given solid mixture into various fractions. The first one, classification. Classification is a method of separating the solid particles into different fractions depending upon their terminal settling velocity in a fluid, so which is also called as terminal falling velocity. The principle behind such a separation is the solid particles, if they are fed into a tank containing a liquid, say water, of large cross section area, the feed stream enters the tank, and since the area of the tank is very large, its horizontal velocity component decreases and the vertical velocity component increases. Then the particles start to settle to the bottom in the given tank. The particles with the larger sizes will settle very fast and get collected almost near the entrance, while the particles having slightly smaller size will tend to get collected in the middle of the tank, while the very small particles, which settles slower than the higher sized particles, will settle almost near the exit of the tank. And still smaller particles, means very fine particles, may not settle at all. They may be carried away along with the fluid. So this kind of segregation of particles according to their size and also their terminal falling velocity, because the terminal falling velocity again depends upon the density, which in turn depends upon the size. So that is how a classification principle help you separate the particles into different fractions. So the device that is used to carry out classification is called a classifier. So we have different types of classifiers. So like gravity settling tank, then you have a cone classifier, then double cone classifier, ray classifier, etc. So let us now understand how a gravity settling tank works. So as we learnt in the principle, a gravity settling tank is a tank of very large cross-sectional area. So apart from the tank, the setup requires inlet and outlet connections to tank for introducing the slurry and to take out the overflow slurry. The tank is divided into a number of compartments, so to collect different sized fractions of materials, and there are vertical baffles between each compartment. So one drawback of the gravity settling tank is that, so since there is a considerable overlap of sizes, then the sharp separation is not possible to obtain from this kind of equipment. So coming to the working of gravity settling tank. So you can see the working principle in the diagram. On one side there is an inlet for slurry and the other side of the tank has an outlet for fluid. The solid particles in the form of suspension in a fluid enters the tank from the feed inlet. As soon as the particles enter, the heavier particles start settling immediately near the entrance. Then slightly smaller particles will settle in the middle portion of the tank, and still smaller particles will be separated out in the last compartment of the tank. So like this, we can have four different fractions of particles separated from a gravity settling tank. So as I already told you, because of the occurrence of the considerable overlapping of sizes, no sharp separation is possible in this kind of classifier. So let us now discuss about the another type of classifier called a cone classifier. So which has a very simple construction. So it consists of a conical vessel that is placed in such a way that its apex is at the bottom. It also contains a discharge launder around its top. So coming to its working, the feed material in the form of slurry enters right in the middle of the cone from the top. The coarse fraction settle out fastly and get collected at the bottom, that is at the apex. So these coarse particles can be withdrawn periodically or continuously, while the fine particles without having settled will move towards the top along with the water, and when the water overflows the cone into the launder, they are carried away in that launder. So, in that way, the fine particles are separated from oversized or coarse particles. So, these are relatively used for a crude work because of low cost of installation. So, these are used in ore dressing plants. It is in plants where ores are being subjected to purification. Now, let us go through a few multiple choice questions based on the topics we discussed in today's class. In classification, the particles are said to be equal settling if they have same terminal velocities in the different fluids, same fluid, same field of force, both B and C. So for the right answer, it is both B and C. If the particles need to settle out at an equal settling rate, then they have to settle in the same fluid and also same field of force is required. So both B and C, it is option D is the right answer. Separation of solid particles of various sizes, shapes and densities by allowing them to settle in a fluid is called classification. Solid particles of different densities are separated by equipments called sorting classifier. So density, if it is used for separating out or separating the different particle mixtures as different fractions, here the density is mainly used as a property. Sorting classifiers employ differential settling methods for separation of particles to make use of the differences in their densities. The right answer here is option B. Fluid medium used in classification technique of mineral beneficiation is air, water, either A or B, neither A or B. So you can either use A or water in a mineral beneficiation operation. Particles attain its terminal velocity when the gravity force minus drag force equals buoyancy force. So the second option is the right option for this question. Sorting classifiers are devices which separate particles having different densities. Option A is the right answer. With that, let me conclude the session. Thank you for being a part of this session. Let us meet again in the eighth session.